Okay, so we said that epithelial tissue makes up both membranes and glands. And among glands, there are different types of secretions that certain glands or certain cells in the glands will produce. So what I want to do is look at three categories of secretions coming from three different glands in this picture. Starting at the top, we notice that we see something called a merocrine gland. Now, if you look at the picture of the cells, the merocrine gland being an example of a type of secretion that a salivary gland would produce. If we look at the cells up in the right-hand corner of the picture, we'll notice that there are parts of the cell called organelles, and we notice that one of the organelles, called the Golgi apparatus, has some vesicles pinching off and carrying the product, in this case it would be saliva, and then the product being transported from the cell and released to the outside of the cell, and of course that would be into a duct, and this would be, of course, an exocrine secretion. And so exocrine secretions put their products into DUCTS, ducts. And in this case, because we are pinching off the product into a vesicle, that vesicle is actually going through a process called exocytosis. It's releasing that product into a duct. We call this a merocrine secretion. Okay, the next type of secretion is something we would see in the production of milk for the mammary glands, and it's called an apocrine secretion. And notice that we also have cells in this case. Again, they have a free end, they have a basement membrane connecting them to connective tissue, and they're also producing a product. But instead of the product going through exocytosis and then being released to a duct, notice that the product actually breaks down part of the cytoplasm of the cell itself, and then the breakdown of the product in the cytoplasm becomes the product. And so once we break down that cytoplasm, to do this again, we have to regrow the cytoplasm, and then we release the vesicles that break it down again to produce the product. Again, this is an apocrine secretion. Finally, we see the type of secretion called a holocrine secretion, which we see this as an example from a sebaceous gland where we're going to produce our product would be oil that will keep the hair from becoming too brittle. And in this case, notice that we obviously don't have simple epithelium, but we have stratified epithelial cells here, and we see that we are actually producing a product, but instead of just breaking down part of the cytoplasm, we're actually breaking down the whole cell, and then the whole cell, as it's broken down, actually becomes the oil and becomes the product that is secreted. Well, since we're breaking down the whole cell and we're secreting the whole product, in this holocrine secretion, notice that the lowest layer of cells next to the basement membrane are actually the stem cells, and by definition, stem cells are cells that are constantly going through division and replacing themselves, because eventually the whole cell will be used as the product. So if we don't keep replacing them, we will run out of the product. Okay, now we've classified the different types of membranous epithelial cells. Let's look at some of the glands that would actually be secreting these different types of secretions, the merocrine, apocrine, and holocrine secretions. So looking at these glands that would secrete these products and put the product into a duct, therefore these would all be exocrine secretions, not endocrine secretions. Notice that we actually have two major categories. We have what we call simple glands, and then we have compound glands. Now, notice in simple glands, there's either no branching or there's only one branch, whereas when we get to the compound glands, there is always more than one branch. Notice that we also have different shapes of each of the branches, and they either kind of take a rounded shape or more of a tubular, sharper shape. Now notice in the first picture to your left, it says simple tubular. Notice there are no branches. You notice that the shape is kind of sharp or spear-shaped or tubular-shaped. Whereas if we go over a few pictures to simple alveolar, then what we have is, again, simple being no branches, but alveolar being more of the rounded shape. Looking at this, so if it says simple glands or simple as part of the description, there is no branches. But if it branches one time, then we call it simple branched. So notice we have simple branched tubular and simple branched alveolar. And the simple branched tubular is more of the spear, sharp-shaped ducts, whereas the simple branched alveolar has more of the rounded circular shapes. Notice again down in the bottom we have the compound glands, meaning that the either going to be compound tubular, compound alveolar, or a combination of the two. Now notice again the compound tubular, we branch more than once, and then the shapes of the actual branching areas are more tube or sharp-shaped, spear-shaped, whereas the branches in the alveolar are more rounded, and the branches in the compound tubulo-alveolar have a combination of being more sharp, spear-shaped, and rounded shapes. So we need to be able to identify these. Again, does it have any branching? Does it only branch one time, or does it branch more than one time? And then what is the shape of the branches? Are they more spear-shaped or tubular, or are they more rounded or alveolar? Okay, so that kind of finishes up our first set of tissues, the epithelial tissues. So what we want to do next is actually talk about our connective tissues. Now, the connective tissues is actually the largest category of our tissues. We have more connective tissues than the others, and it's the most varied of our tissues. So why do we classify connective tissues as connective as opposed to epithelial, muscular, or nervous? So the characteristics we want to look at is that the connective tissues all have very specialized cells that make them up, and then they have material outside of the cell that we actually call non-cellular matrix. And that non-cellular matrix is either going to be very fibrous or have a lot of protein fibers in it, therefore we see the term fibrous, or it's going to have some fibers in it, and then it's going to have also something called a ground substance. Now, they all have a matrix which is made up of protein fibers and ground substance. It's just the proportion of the protein fibers to the ground substance will determine what their subcategory will fall into. So they all have specialized cells. When I say specialized cells, such as a blood cell like a leukocyte, or the specific leukocytes is a specialized cell. A bone cell, such as an osteocyte, is a specialized cell. A fat cell, such as an adipocyte, is a specialized cell. A fibroblast is a specialized cell. So the actual cells, instead of just being determined by their shape and arrangement like they are in epithelium, the specialized cells actually have specific names and do specific jobs. But the material outside of the cell, which is non-living material, is actually called matrix, and it's actually going to be made up of protein fibers and some sort of ground substance, which can vary. Anything from the ground substance could be something like water. The plasma of the blood, for instance, would be the matrix, but the ground substance in the plasma would be water, to something like chondroitin sulfate, which would be the ground substance in something like bone. But anyway, let's look at some of these and point some of these characteristics out. The first and most widely distributed connective tissue is areolar tissue or areolar tissue, and this is the falls into the category of being a loose, fibrous connective tissue. And this is a connective tissue. When we say loose fibrous, notice that there are fibers, there are protein fibers such as collagen fibers and elastic fibers, but they're not densely packed. They are part of actually the extracellular or non-cellular matrix, but there are also several living cells within this tissue. Notice we have everything from lymphocytes, mast cells, to fibroblasts or macrophages. Fibroblasts being probably the main type of cell in the fibrous connective tissue, because they're usually the cells that produce the protein fibers. Now, this particular type of loose fibrous connective tissue, this areolar or areolar tissue, is very pliable. It actually, we find it holding certain tissues together, like when we talked about epithelial tissue and we said it has a basement membrane at one end. A lot of times that basement membrane is next to this areolar tissue, and then this areolar tissue is the first of the connective tissue, and then there may be other connective tissues under it. Anyway, it makes up fascia. A lot of this glistening tissue that holds things together. Again, it's the most widely distributed tissue. Next, we see adipose tissue, which adipose tissue is made up of adipocytes, or these specialized cells. Its main job is to store fat. Now, again, we see that in the non-cellular or extracellular matrix that it's not densely packed with fibers, it's loosely packed. Again, this is another tissue that's very pliable. Its main job is energy storage, but it also helps in protecting organs and even insulating us. Especially in the picture we see the subcutaneous fat. Another loose fibrous connective tissue is reticular tissue. And we see reticular tissue in different organs and places in the body, especially these places that seem to be like a type of a filter for a fluid. Whether that fluid is blood or lymph or other fluids in the body, reticular tissue allows the fluid to flow through it while serving as a kind of a screen. Now notice our actual fibers are reticular fibers. There's a lot of space between the fibers. There are also living cells. This tends to be a place where a lot of white blood cells tend to congregate and stay in this for periods of time and then move on to other tissues such as blood or other reticular tissues, especially in things like lymph nodes and the spleen. But this reticular tissue is very important in areas where we need to basically filtrate out different fluids for different reasons, and they house a lot of different cells, especially white blood cells. Okay, now our next category is still fibrous tissue, but this time it's dense fibrous tissue, and we have what we call dense regular and dense irregular. Well, here we see an example of some dense regular tissue. Notice how when we say dense, notice how the fibers are densely packed. We actually have some living fibroblasts in these. Our fibers are, in this case, because we're talking about tendons, which are connecting muscle to bone, in this case, the protein fibers tend to be collagen, and of course, these are very strong. These fibers are very strong in the direction that they are running, but they tend to be damaged if they have a great amount of tension pushing on them from an area other than the area that they're running. So when we say dense regular, we mean that all the fibers are generally running in the same direction. The advantage of that is it gives strength. The disadvantage is that it's not as pliable, and if a lot of force is put on it from another direction, it does tend to tear or damage. Now we see an example of dense irregular connective tissue. Irregular meaning that in this case, the collagen proteins are running at all kinds of different angles. They're not all running in the same direction like they would be in the dense regular connective tissue, but in this case they're running at different directions. And again, this is the type of tissue we would find in our deep dermis, our dermis, this lower, thicker layer of skin. And of course, the advantage of this is the fact that because we have fibers running at different